Thank you for joining us for this DDI CADcast. Today's topic is What's New 2015 SOLIDWORKS Plastics. Today we're going to be touching on several topics involving plastics. Here's a quick list of what we're going to be covering. The first item involves mesh improvements. We have a couple more options when it comes to the mesh, both with the tetrahedral mesh and the hexahedral mesh, that will help us in this new version of 2015. Let's start with the tetrahedral mesh. Let's make a new solid mesh here. Now before I jump into the different mesh elements, let me just talk about the UI change here that has happened in 2015. As you recall, in 2014 we had some larger pictures with checkboxes referring to cooling channels and the mold model that we could use. In 2015 we still had that functionality, however we did get rid of the extra pictures in favor for checkboxes. Let's go ahead and choose the runner and cooling system design, and this basically will take you in. Let me just use the same settings as before. This will basically take you in and allow you to create a cooling channel with sketch geometry without having to do this as a separate step inside of your plastics design tree. We'll do a quick mesh. Now the enhancement is going to be for the tetrahedral mesh element types. And the enhancement is related to the runner. If you've chosen to create this idealized runner and sprue design, and with that checkbox on for the runner design, we have the option to choose the advanced button in this particular pane. And this will give us access to enter values for the ring count, the ring cut count, and the length ratio. If I click OK on these, we can take a look at what these values will yield. So there's my ring count and my ring cut count. This will allow us to tighten or coarsen the mesh with the new advanced button in 2015. Now I just noticed that I used the cooling channels workflow instead of the runner design. I guess we learned something new here. We can also use this for cooling channels. Next, let's talk about an enhancement with particularly the hexahedral mesh element types. We have some new functionality that will allow us to conform to the surface geometry of models using the voxel mesh type, like you can see here in our screenshot. Let's go check that out. So going through our solid type workflow, if I choose the hexahedral mesh element type, we have this new option for a non-orthogonal voxel solid element type. Let me go and transform that. If you look at here now, we are looking at a very coarse voxel hexahedral mesh element type. If I switch this over and I delete this, and I choose the new non-orthogonal voxel, this new algorithm conforms the elements at the surface so you get a better representation of the model geometry now with the hexahedral elements. Again, you still get the benefit of accurate results with less calculation time, but now we can conform to those surfaces with more accuracy now that we don't have to worry about the brick-looking mesh element types. The non-orthogonal will allow us to stop short and respect those surfaces. Next, let's talk about a new utility called the Nominal Wall Thickness Advisor. The Nominal Wall Thickness Advisor will let you study the wall thickness throughout your model, and is available for all flavors of SOLIDWORKS plastics. Let's take a look. To turn on the Nominal Wall Thickness Advisor, we'll come over to the plastics tree, do a right click and choose Open Advisor. And you can review your wall thickness both as a percentage based off of a nominal wall thickness here. We can see how much we deviate from that wall thickness. Or as a global wall thickness plot throughout the entire model by the value radio button there. Again, this is a nice utility to give you some insight to see as to how your melt will be distributed throughout your model during an injection. The next topic is symmetry analysis with SOLIDWORKS plastics. Now we're always trying to save calculation time, and when your model is symmetric or cyclic symmetric, you have the opportunity now to set symmetrical runners. Now this functionality is only available for tetrahedral meshes only, and it's available for SOLIDWORKS Plastics Professional and Premium only. On the screen are some additional bullet points that are to take into consideration as well. Let's jump into SOLIDWORKS and take a look at setting symmetrical runners. Now again, you want to make sure you turn on runner and cooling system design checkbox. And we'll mesh the model. And we'll make sure that we choose tetrahedral mesh. Once chosen, you're going to get an opportunity to select Set Symmetrical Runner. You have several flavors of symmetric runner types you can choose from. Once you're done selecting your runner type, click Transform and finish through the mesh creation process. Now the biggest caveat to this functionality at this time is that you cannot display symmetrical results. The results will reflect the fact that it is a portion of the overall system, but it will not display those results as of yet. Here are some additional orientations that can be modeled using the new Symmetry Analysis option in plastics. The next new functionality to cover is we have e-drawing support now in SOLIDWORKS plastics. That's right, we can go in and open our results, and at the bottom of the results pane we have an opportunity to choose to save to an e-drawings file. Now you can export vector plot results such as weld line, air trap, and velocity vector information, but we can grab all the other different plots in the lists. Let's open up our flow results. And any plot is up for grabs here. We can go in and choose the export to e-drawings icon, choose where to save our e-drawings file. I've actually saved a couple here for us already. And we can interrogate these results without having to have SOLIDWORKS plastics loaded. This is great again for collaboration amongst people that have SOLIDWORKS plastics and do not. Here's a pressure at end of fill model. And that's e-drawings with SOLIDWORKS plastics in 2015. The last topic in SOLIDWORKS plastics, what's new, is our new venting analysis plot available for SOLIDWORKS Plastics Professional and SOLIDWORKS Plastics Premium. Now in the current screenshot we can see the venting pressure plot showing the high pressure areas that may need to be vented out to prevent burning to the material or defects to the material in those areas due to the pressure, the high pressure. Let's open up SOLIDWORKS and let's turn on the venting analysis in SOLIDWORKS Plastics and show where we can add actual air vents to remedy those high pressure areas. The first thing you need to do to turn on the venting analysis is to go over to the Fill Settings folder under Process Parameters. And towards the bottom you'll find in SOLIDWORKS 2015 a new section called Venting Analysis. Go ahead and checkbox that on and run your flow analysis. Once you run your flow analysis, you'll look at your results, you'll look at the venting pressure plot. At that point you want to look at, let's go back to our model here, our screenshot. You can see we have two high venting pressure locations in our results. At that point you can go back to your SOLIDWORKS plastics tree and add air vents in those locations. You can see we previously added 2 additional air vents. And rerun your plastic study. Once I reran my plastic study, we can go back to the venting pressure plot, and we can see we no longer have the high pressure buildup in those areas. So that sums up the topics for 2015 SOLIDWORKS Plastics, What's New? For more CAD/CAS topics, please check out our YouTube channel at www.youtube.com/ddicad, as well as additional tech topics at ddicad.com/techcenter. Thanks for watching.